Welcome to Triomeet. Let's solve exercise 3.1. Let's read the question. In which of the following examples of motion can the body be considered approximately a point object? So the question here is, how do you identify an object that is in motion as a point object? So what is a point object? Suppose I have an object here and I'm observing it from a very far distance. It's very large distance in between my eyesight and the object here. Then this is considered to be a point object. This is if it is stationary. But what if it is moving? It's an object that is moving. So in this case, if we have a car here that is 3 meters in length, right? A car that is 3 meters in length, and it has covered a distance of 10 kilometers. Then can we say that this object is a point object? Yes. In this case, the car will be a point object. Why? This is because the distance covered by the object is large compared to the size of the object. The distance covered by the object is very large compared to the size of the object. Why this is like 10,000 meters, right? This is very large compared to 3 meters. 10 kilometers in meters is 1 kilometer is 1000 meters. So 10 kilometers will be 10,000 meters. So this is when it's very large. When compared to the size of the object, then it's said to be a point object. Now, so we can say that will be a point object. Now what is the first part of the question? The first part of the question is a railway carriage moving without jerks between two stations. So we've got a station A here, we've got a station B here, and suppose the distance between these stations is very large, right? And we've got a railway carriage here, okay? Railway carriage. Now compared to the distance between two stations, the size of the railway carriage is small, right? So in this case, we can say that it is a point object. What about part B? There's a monkey sitting on top of a man cycling smoothly on a circular track. Now consider that you're on a very small cycle track, right? So we know that in every position you have to keep on changing, right? It won't be a smooth track. But if the distance is very large, it's very large distance in our movement, then the movement is supposed it will be very smooth if the distance is very large. Why? Because if it's small, it'll keep on, it's like continuous change, right? You continuously have to turn your bike, so then it's not a smooth travel. They've mentioned smooth here. So if it's a large system, it's a large circular track, it's a big circular track with a large distance, then it will be a smooth track. So in this case, they mentioned it is smooth track. So that means the distance that we have is very large. The distance here is large. It means that they are point objects because distance is extremely large. We've got the man and the cycle here, the monkey on top of this man. It becomes like a point object because the distance here is large. If it's a smooth travel, that means the distance here will be the distance traveled will be large. So this is also a point object. Now the third part of the question. A spinning cricket ball that turns sharply on hitting the ground. So that is what is it saying? We've got the ground, suppose is the ground. The cricket ball is spinning and then it hits the ground and it turns sharply once it hits the ground, right? So what is the reason for this? We know that when the ball hits the ground, there'll be friction coming into play, right? If there's a friction acting between the ball and the ground, then that means it is not a point object because friction won't act on a point object. Only when the size of the ball is considerable can friction act. So when this ball is suddenly there's a turn, there's a sharply on hitting the ground, turns sharply on hitting the ground. That means this is not a point object. This is not a point object. Now, fourth part of the question. A tumbling beaker that has slipped off the edge of the table. Suppose the table, there's a beaker here. It is about to fall. So it falls. Right? It's said it is toppling. It is a tumbling beaker. Tumbling beaker that has slipped off the edge of a table. So this cannot, if it is falling, it is because of the size, it will topple, it will vibrate or something like that when it falls down, right? So this is not possible for a point object. Therefore, this cannot also be considered as a point object. So in this question, the only 2 point objects are a railway carriage moving without jerks between 2 stations and a monkey sitting on top of a man cycling smoothly on a circular track. Let's solve question 3.2. The position time graphs for 2 children A and B returning from their school O to their homes P and Q respectively are shown in figure 3.19. Choose the correct entries in the brackets below. So the first question we have to determine who lives closer to the school. So this is a distance OP, this is a distance OQ. So since this is a position graph, we can see that OP is less than OQ. The distance OP is travelled by A. So then we can say A lives closer to the school than B. Second part of the question. A or B who starts from the school earlier. So we see that A starts from the school from this time, T starts from the school from this time. So from the graph, we can determine that A starts from the school earlier than B. What about third question? A or B walks faster. Who travels faster? We have to find the speed. So in this case, the steeper slope is of B. There's a steeper slope. So if it is steeper slope, that means slope of B is greater than slope of A. Now what is slope? We can find slope by doing y2 minus y1 by x2 minus x1. So what is in the y-axis? It is position. What is in the x-axis? It is time. What is position by time? Speed. So that means we get VB is greater than VA. That is speed of V is greater than speed of A. That is B walks faster than A. Now the fourth part of the question. They reach at the same or different time. From the graph we can see that they reach at the same time. Now, fifth part of the question. Does A or B overtake B or A on the road once or twice? So from the graph we can see they are intersecting at one point. And we see that B's speed is greater than A's. That means B is overtaking A once. So we see B overtakes A on the road once. So this is the answer for this question.